Hi folks, welcome to the third lesson on gaseous equilibria. We've already looked at partial pressure and mole fractions and how to create an equilibrium expression from a balanced equation. And now we're going to look at how to perform calculations involving Kp. So that could be trying to work out Kp, from partial pressures, or perhaps trying to work out a partial pressure of one of the reactants or products if you're given Kp and some other values. So I'm going to chuck you in the deep end. This next slide has got a question on it, but you should be able to answer the question with your knowledge from the previous two lessons. So let's have a look at that. Okay, so it's a multiple choice question. It's about sulfur dioxide reacting with oxygen to give sulfur trioxide. That's an important step of the contact process used to make sulfuric acid, which is, probably the most important industrial chemical there is out there. Anyway, we've got this table full of delta H of formation and some entropy values. And to be honest, that's just thrown in there to confuse you and, add some extra info that you don't need. And the information you need is down here. Okay, we know it's an equilibrium. We know it's at a constant temperature, 585 Kelvin. And it's got a constant pressure, 540 kilopascals. And it occurs in a constant volume, which is good, yep. And then it tells us, this is the really important stuff, it tells us the number of moles of each of the three gases. Okay, and if you look at the ratios there, we've got 5 to 8 to 7. Okay, so using those molar ratios, we can work out the mole fractions of each one. Okay, so to work out the mole fraction of sulfur dioxide, in this case, we'd have to just take 5 and divide it by the sum of all of them, 5 plus 8 plus 7, which gives you 5 divided by 20, which is a quarter, or 0.25. And that means that the molar fraction, which remember can never be more than 1, the molar fraction is 0.25, which basically says that of the molecules that are in that whole mixture, 25% of them are going to be sulfur dioxide. You can do the same thing for oxygen and for sulfur trioxide. And then once you've got those mole fractions, you can work out the partial pressures by multiplying them by the overall pressure. Whoops, I shouldn't expose that so quick. By multiplying the mole fractions by the overall pressure, that gives you the partial pressures, okay, which we're going to need to then put into the equilibrium expression. Okay, so it's a couple of stages. There's another little catch here as well. They don't want the answer in kilopascals, they want them in megapascals. So we have to multiply this figure, rather divide this figure by 1,000. Okay, so we'll end up with 0.54 megapascals. Okay, that'll be our total pressure. Okay, so first thing, write out the equilibrium expression. And this is what we get here. Yeah, this 2 should actually be subscript, by the way. So, and then over here, we've got the values plugged in already, okay? So the 0.54 refers to the 0.54 megapascals, okay? And these other decimals, 0.35 refers to the mole fraction of sulfur trioxide, 0.25 mole fraction of sulfur dioxide, and 0.4 is the mole fraction of oxygen, okay? And if you work this out, which isn't terribly easy on a calculator, so I would recommend, first of all, doing these on, Google search. You can learn how to do calculations on Google search. We looked at that last year. Because then if you make a mistake, you can always go back and change it. Whereas on a calculator, if you make a mistake with the parentheses or the memory storage, it's really a problem. It's quite easily done. Anyway, if you get that all right in your calculations, then you'll come up with this value, which you can see is C. Now, the units here, overall, that should be a capital P, by the way. Overall, it's megapascals, and you can see that these two are going to cancel. We're going to be left with 1 megapascals at the bottom, so it's megapascals to the -1. So next, let's have a look at using ICE tables to solve equilibrium expression problems. And this is something you've done before with Kc. So let's just go through the steps that you've used before. Okay, so first write out your balanced equation. You can see everything there is in the gaseous state, including the iodine vapor. Then you want to have your 3 rows beneath, yeah? The initial, the change, and the equilibrium. Okay, and in this case, they're going to be measured in megapascals. Then fill in any values that you're given, and the values that you're given will usually be in the initial row, okay, the start of the experiment. So let's say we're given these values, okay, no products yet, just 2 reactants, okay, and these are partial pressures for those reactants. And then you're going to need to work out some sort of variable that expresses the stoichiometric ratios, the molar ratios, and how they're going to decrease for the reactants and increase for the products. So the ratio here is 1 to 1 to 2, which means that if we react 1 mole of hydrogen, you're going to also react 1 mole of iodine, and that's going to produce 2 moles of hydrogen iodide. Okay, so that would be looking something like that. And then you just combine each of these rows for each of the different 3 species, and you end up with those values there. Okay. And now finally, you're going to plug in these equilibrium, the equilibrium row only, these values into an equilibrium expression, and try and solve it for x. Okay. Usually in this case, you'd be given Kp. You can't solve an equation, unless you've got simultaneous equations. You can't solve an equation with 2 variables. So you'd be given Kp and you'd have to work out x. Okay, sometimes you might have a similar scenario like this, but you would be given x and you'd have to work out Kp. Okay, beware that sometimes when you solve these, you'll end up with a quadratic equation. So you might have to use that quadratic expression, the one plus or minus b square root. I don't know, it's a mathematical one. You know it better than me. Yeah. Okay. So after this, there are 3 slides of questions that I'd like you to do and some homework. Okay, so the questions already have the answers on the slides, but the homework is 2 separate sheets. I think they're chem sheets. And if you can just work through those and then check the answers are also provided on the slides. Okay, best of luck, and I hope everything's clear. Over and out.